This is a question from one of the hardest year 10 papers. So we're asked to solve for theta to the nearest degree. So we'll start by combining all of our terms onto one side. So 5 cos squared theta sine theta minus sine cubed theta minus cos theta sine theta minus sine theta equals to 0. So you may notice that all of these terms have a sine theta in common, so we can go ahead and factor it out. So sine theta times 5 cos squared theta minus sine squared theta minus cos theta minus 1 equals to 0. Now you may notice in this bracket, everything's a cos theta except for the sine squared theta. However, we can rewrite it using Pythagorean identities. As we know, sine squared theta equals 1 minus cos squared theta. So let's rewrite it as that. Sine theta, 5 cos squared theta, minus 1 minus cos squared theta, minus cos theta, minus 1 equals to 0. Now, we can expand this bracket. This is just a minus 1. And then we can times each of these terms by this minus 1. So this becomes sine theta, 5 cos squared theta, minus 1, and 2 minuses make a plus. So plus cos squared theta minus cos theta minus 1 equals to 0. Now these are like terms, so we can combine them. So sine theta times 6 cos squared theta minus cos theta, and then this minus 1 and minus 1 will become a minus 2, and that equals to 0. Now we can use now factor law. As we know, if two things time to become 0, either A equals 0 or B equals 0. So we can rewrite this as sine theta equals to 0, or 6 cos squared theta minus cos theta minus 2 equals to 0. And this is because of now factor law. So let's solve for sine theta equals 0. If we do sine inverse of 0, we're left with theta equal 0 degrees. Because remember, sine theta is just the height. So sine inverse of 0 is equal to 0 degrees. So now we know on the unit circle, it will have to be 0 degrees. Which points are at 0 degrees? So it starts off at 0 degrees. Then when it goes to 180 degrees, it's also 0 degrees. So 180 degrees is a solution. And if we go all the way around at 360 degrees, that's a solution. And we stop there because our domain is between 0 and 360. Now, let's solve this. We can use the cross method to factorize this. So 3 cos theta and 2 cos theta. Okay, let's see. What are some factors of 2? We can write this as negative 2 times 1 or as negative 1 times 2, right? Now, let's test. Let's test negative 2 and negative 1. Negative 2 and 1. So negative 2 will become negative 4 cos theta, and this will become 3 cos theta. So this will become minus 4 cos theta plus 3 cos theta, which gives us minus cos theta. So that means that this is a way to factorize it. So we can rewrite this as 3 cos theta minus 2 times 2 cos theta plus 1 equals 0. Now, again, by now factor law, we can write this as 3 cos theta equals 2 or 2 cos theta equals minus 1. And we can write this as cos theta equals 2 over 3. And cos theta equals minus 1 over 2. Now, let's do cos inverse of 2 over 3. That gives us approximately 48 degrees. So cos inverse 2 over 3 equals 48 degrees approximately, because they're asked to do it to the nearest angle. Sorry, the nearest degree. So as we know, cos theta is positive in these two quadrants. And we can get the related angle by 360 minus 48 degrees, leaving us with 312 degrees. So therefore, these are two more solutions. Now let's solve cos theta equals negative 1 over 2. Cos inverse 1 over 2 is 60 degrees. However, we're looking for when it's in the negative quadrants. So based on all stations to central, we can see that cos theta will be negative in this quadrant and this quadrant. And we can get its angle through 180 minus 60, which is just 120 degrees. And 180 plus 60, which is just 240 degrees. So therefore, our final answer for this question will be 0, 180 degrees, 360 degrees, 48 degrees, 312 degrees, 120 degrees, and 240 degrees.